if we have to fit the saddle to a horse correctly, we need to know where the difficult points in the horse's exteriors are. We also need an overlook over the horse and a rider because we see them for the first time. Here we have a Grand Prix mare by Accent Alabaster out of a Weltmeier mare. This bloodline produced quite difficult horses exterior-wise. As you can see, you have rectangular shape. You have a rising top line from behind the withers to the croup. And the hind is quite straight. So the goal we want to achieve is we want this hind underneath here. So therefore, we need to enable the horse to do this function because anatomically we need the freedom of the back to have the hind moving forward underneath center of gravitation, which is about here. To go through the horse's body to find the crucial points, we always look at the entire horse. That means we start with the teeth. If teeth are managed, the horse is usually managed. Then we see this muscle, brachiocephalic, which is going from the upper arm all the way to the neck, which is compensating for a low back. If you want to understand horses' biomechanics, the first thing you need to know is that the back, the thoracic lumbar part, and the cervical part are in an indirect relationship. That means in nature, if the back goes up, the neck goes down. If the back goes down, the neck comes up. So it gets dangerous if we have a back which is low and a neck which is low. So our job as saddle makers is to place the rider's weight on the horse where the horse can easily do this. That means a horse can carry a lot of weight underneath where the rider would sit without saddle. So this is what we do. We measure top lines, then we calculate the seat of the saddle just to make sure the rider's weight stays here. If we put her original saddle on it, you see, you have one crucial distance. This is the one from the head iron, which is here, to the deepest point. Most of the horses measure from scapula to the deepest point of the top line about 20, 21 centimeters. So, of course, we cannot ignore that distance. It would mean that we would have the same distance in the saddle as well to achieve what we see here, a correct distance to the scapula, from the scapula to the deepest point, and freedom in the back. So like this, we get the rider's weight underneath, and this function is easily provided. The horse is interested in getting free here because here is no support. And the more we work here, the more the back goes down and the hind goes away. If you go through a horse's back, after checking teeth and brachiocephalic, you go on top line, just follow if you find any sore points, which is not the case here. Next thing is you follow the edge of the panel with a slight pressure to find congestions, which is not the case as well. Same thing on the other side. Then one important thing is the incurvation of the horse. You see, every horse is left or right-handed due to either riding or some physical issues. To find that out, you give a little impulsion here. You see a reaction on longissimus dorsi. Do the same thing on this side. You see there's no reaction. This horse is incurvated to the left. It's usually due to right-handed riders, which are collapsing the left hip, pushing the horse to the right. So this horse bends easier to the left, but it's more correct to the right. So it means that this leg, the left hind leg, is slower than the right. So as you have seen in practice, the rider's job especially is to make both hinds to equal speed. and to equal transmission. This is the most complex thing in riding to get the horse straight. And saddles, if they influence the horse's back here, so you get a reaction immediately. While you do it here, nothing happens because this is all very solid here. This is it.